Now we are going to use these register to program in embedded C so that we can toggle an LED in my motherboard. Actually, my motherboard contain motherboard that I have. Give me a sec. My motherboard contain a LED which is connected in the RD port D. Right. So let us explore the port D now. The same configuration we can use with port D as well. Maybe their configurations and data register will be different. Right. So because I can only toggle the LED which is connected in respective port. That's why we are coming here. Port D is an 8-bit port. Commit trigger input buffer. Each pin is individually configurable as an input or output. Port T can be configured as an 8-bit wide microprocessor port, parallel slave port by setting the control bit PSP mode. Tris E. In this mode, the input buffers are TTL, meaning so you can use this port D bits as port D pins as parallel slave port, meaning you can write data to a slave device which is accepting data in parallel input, right? In that case, for that you can use it, but what we are going to do is we are just going to use them as IO pins only. So if that is the case, what we have to do? Port D, which is port D data direction register. Then tris E. In this tris E, PSP mode is the bit right now. What this bit may, I think we are not going to use that as parallel slave port, right? If we want to use that as a, if we don't want to use that as a parallel slave port, we have to configure this PSP mode bit, right? What we have to configure, that we will see. It is part of port E. Sorry, tris E. So parallel slave port mode select bit. Port D function as parallel slave port. Port D functions general purpose IO port. Now I am going to toggle an LED which is connected in the fourth pin of port D. Actually, port D is a register which is mapped with IO pins. Right now, we have a pins in a microcontroller. In that pin, D4 pin, port D fourth pin is connected with a LED in my motherboard. So I want to toggle that LED. Toggling means I want to blink that LED. If that is the case, how to write the program? So to write the program, first thing is I have to make that pin as general purpose IO pin. I should not use that as parallel slave port pins. When we do like that, the function will be a little bit different. So first I have to do that. Once I do that, and then I can you configure the tris D register to make that pin as an output. After that, using a while loop, I can toggle it. So if we do like that, I can make my LED blinking. This operation in real automotive to turn on these warning LEDs or telltales, we use them. But there we use with condition. If there is a fault, you make that particular pin to high so that that particular LED will low. Right now. So like that we used to program. Shall we program that now?
Yes, sir.
If
By
we want
default,
to.
it will be
Hmm.
in general purpose only, sir. Like whenever we want to use any port, so
Actually, the port are multiplexed. The same port, port D, if I want to use that as parallel port slave pins, meaning I want to interface a slave parallel port device, a device which accepts the data in parallel, I can use the same port D pins. But in order to do that, I have to set this PSP mode bit to 1.
okay,
When I want to use the same port D pins as just simply an IO pins, so that I can make any pin to low or high, something like that, in that case I have to set this PSP mode bit to 0.
okay.
Understood?
While configuring first, we need to put this PSP mode to 0,
Yes.
and then we need to configure. Then we need to make it use the other TRISA registers, right, sir?
Yeah, like
This
that
is the
only.
first step.
First step, because if we don't do that, it is an ambiguous whether we are using it as a parallel slave port or general IO port. That is not that is not known to system. But anyhow, by default 0, every register will have a 0 as the value by default. So if that is the case, this will work as an IO pin by default. Though it is so, it is our responsibility to ensure that we set the PSP mode bits to 0. Understood?
Sure. Sir, like until now, like we have went through the registers like for each ADC and analog output, digital output, like that. So for each, we can take one example for each thing, and what are the steps? What are the first steps we need to do? Like for example, for this PSP mode, first we need to put 0 like that. We can do one example, sir.
This we are going to do now.
Yes, sir.
So first thing is we will create a toggling program and we'll execute that in the hardware so that that toggles our LED that we have in the motherboard. Right. Why
Yes,
I chose port D? Because in my motherboard they have connected the LED only in port D. Otherwise we might have done it with port A. So let us start the program. Give me a sec. Let me up the IDE. For that we have to up the IDE, MPLAB IDE. Let me bring IDE. So I up MPLAB IDE. This is my old program that I have. I just to close this. Done now. So now to create a new project, come here and then select new project. So we store that under embedded C directory that we have now. I think I have not created any repository for your batch yet, I believe, if I'm not wrong. So today I will do that so that we will have the files in centralized location. It is an application projects. So we have to choose. So this is the controller that we are using. You can use simulator initially. So you have to choose this compiler while you are creating, because we are using a C compiler here. Then we have to give a name. We are saying like it is our IO port, right? We can store that in a location. right now. We can store it under embedded C. Then I believe that's all. Right. So once we get that, we have to add the source file. For that, you select new and then main.c. So file name, we can say the file name as LED. Right.
Yes.
Let me rename this as LED toggle. Otherwise, we can say warning. Let us use automotive terms. Telltale. Right. Here, we have to make some pragma settings. Those were used as a configuration for controller, like what type of clock that you are going to use, those stuff. We have some settings for that we tried and it is working. We just bring those settings here. Those are settings for controller and motherboard. It will vary, depends on the motherboard that you are using. Right now, there won't be much change. So based on your board design, you have to set those parameters right now. So let us bring those settings now. So for that, I have to go to, give me a sec, D colon and Hasia software. Then projects. Here can projects, current project X. So you are seeing, I believe you are seeing my desktop right now. These
Yes,
are
sir.
those settings. First, what we are doing, pragma config FOSC, INTRC clock out, meaning that we are using internal clock oscillator. SC means function on RA4. So this is like we are using an oscillator circuitry, meaning we have a crystal oscillator outside which supplies the clock signal to us. Right. Then we are configuring WTTE, watchdog timer enable bit. We are turning it off. We are not using timer not as a watchdog timer. So there won't be any watchdog timer operation. I think we have studied about watchdog timer, which is used to reset the microcontroller when something hangs. Right? Usually people used to load it with some value after some programming line. If again they will reset it. So like that they used to do. And then power up timer enable bit. This is another bit that is also we disable. Right. And then code protection bit that is turned off. We are not using any code protection. Data code protection bit that is also turned off. Brownout reset selection that is also disabled, meaning that when the voltage is going below the normal operating voltage, they will move this one to, they will reset the microcontroller. We configure that not to do that. Right. Then IESO, internal external switchover bit, that is turned on. FCMen, failsafe clock monitor enable bit, that is also turned on. Low voltage programming bit, that is also turned on. So these were turned on. I believe these are the settings. And brownout reset selection bit, we are setting that voltage. Then what is the voltage in which they have to move to brownout. That means they have to push the microcontroller to idle. That is defined as 4 volt. Then WRT, flash program memory, is a write enable bit. This is like a write enable protection bit, that is also set to 0. So I just copy these settings because I have to keep this setting in order to work with my motherboard. Just to copy it, I bring that to top of my program.
So this
Okay, done.
on-off variables and all, where it is this depends, sir?
It is actually these on-off configuration registers. They have a location, memory location, right? That memory location doesn't have a physical register. So when you set these values, automatically it will go and set the flags in the memory of microcontroller. Right. For a detailed description of these settings, I believe it is part of datasheet. It should be there in the datasheet. I think here it used to be device configuration. Mhm. That's there is a configuration device overview. Let me just search for config. But this will be, I think it is part of data sheet that used to be explained somewhere. This is packaging information, then revision history, device difference, conversion. Where is that? EEPROM. Configuration. They used to like configuration setting. This is configuration preset 14.1. When the program memory is code protected. Code 14, section 14.1. Here. Actually, there is no memory location called 2007. It is not actually 1FF, up to 1FF only we have memory locations in that memory microcontroller. Then what is this 2007 address? This address is a virtual address. When you write something to this address, that will go and set these parameters. Right. flash memory write enable bit, and then in-circuit debugger mode, flash program memory code protection bits, low voltage programming, brownout reset enable bit, power up timer enable bit, watchdog timer enable bit, whatever that I told, no. But this is not a physical memory location in the memory. There is no memory location. If you look at the memory map of that microcontroller, you won't find a memory location called 2000H. But when you write something to this 2008, 2007, it will go and write these parameters. Those are different flags in the microcontroller. Understood? So it is used as a configuration bits. So you have to do that via this pragma directive. That means before you build your binary, you will make these settings. Only after that only you will go for building binary. This is because the pragma is a preprocessor directive right now. So before they create binary itself, we have to be ready with these settings.
Yes, sir. This int INTRC clock out. So these are like variables, right, sir? These has values.
Values, yeah.
Where it is different, sir?
Okay, those were defined in this maybe this IDE right now. This MPLAB IDE, they have constant definition. All that is there in this particular that is associated with this IDE. When you use these constant, automatically, for example, INTRC clock out means they may have defined INTRC clock out for what they are giving it, FOSC. See, this is 2 bits right now, FOSC not FOSC 1, right? So either you can do oscillator selection bit. So what we are setting actually INTRC clock out. So but we didn't define what is INTRC clock out. That is there in the defined in the IDE itself somewhere. So they will use either you can do like that, otherwise you can give the numerical value u equal to for equal for that. So internal clock circuitry, RC oscillator, SS oscillator, XT oscillator, LP oscillator. Maybe we can go for 10, meaning 2. When you set 2, automatically they are giving value to FOSC2 high speed oscillator. Right now, like that, we can give some value here. Maybe I can say like this, so that it will become a high speed oscillator circuit. Right.
Yes. So these are built by inbuilt in the IDE, on off.
Inbuilt in the IDE, the constants are defined in the IDE. We can directly use them when we use that. Otherwise, if you don't want to use them, the constant, if you don't want to use those constant, you can directly give the numerical value.
If
Here
you
as
have not written this pragma, these headings, sir, what will happen? Like some.
it will assume a default things. That is while we are not sure what settings they have by default in this IDE right now. With that default setting, it will go and will create the binary. That binary may work or may not work, because these are the board related parameters that we have to define. If we don't define these parameters according to our board and controller, they are undefined. If they are undefined, the output behavior will be, output is not predictable.
Yes, sir.
Understood?
Yes.
So with that, we go here. We have to include this library too. What we have to do first, we are going to write program here.